crazy. I did not expect this many people. Welcome to Orchestructure. This is July. We're at Criteo. Thank you to them for letting us host, and they're thinking about coming on as sponsors as well. I have a couple minor announcements from myself, and then I'm going to have Archie here from Ithaca come up, one of our sponsors, and just talk about some of the things that they're working on, what they're looking for. And then I'm going to hand it over to Andrew and David for their presentation. So my first announcement is that I am co-organizing the DevOps Days Detroit event in October this year with Archie and with others. It is happening October 3rd and 4th. I think it's a Wednesday and Thursday. We put it in the middle of the week to make it as hard as possible to schedule for you. And it is, call for papers have been open for a few months, and we just opened registrations. I believe it's $150 a ticket, and there are 350 total spots available. So definitely talk to me if you want more details about what's being presented, what's being talked about. We're putting things on the website as well. We're getting a lot of sponsors. And if you want to talk about something that you're working on that's related to DevOps at all, we would definitely love to hear from you. Even if it doesn't work out, even if it's a workshop format, even if it's an Ignite or a 5-minute talk, something like that, we'd love to hear from people around this area. So the other announcement is that I just started a new job, so I've been incredibly busy. I'm working for a place called StockX, which is under the Quicken Loans family of companies. They are a new e-commerce platform. They're actually in Detroit and One Campus Marches. So I'm driving there right now, and I'll eventually move out of Ann Arbor, but not too far. So Orchestructure will continue on with me and Bob and some of the other people that have been helping out for a while, continuing to run it. What's cool is StockX is a SaaS platform. It's an e-commerce platform. Where I was before, Liquid Web was kind of a platform as a service. And so there's some interesting challenges that are slightly different. And I intend to bring that to you guys in form of lightning talks from some of the people that I'm working with, et cetera. So I'm leading the DevOps team there and the efforts as we go from like a bunch of devs just pushing code over the wall and hoping it works and not breaking production to actually putting in CI/CD and other more reliable things in place, plus moving to GCP from AWS, which should be interesting. Lots of fun stuff to come. We're booked for the rest of the year for presentations. So events should be planned relatively quickly, and look forward for some really good talks coming up. Archie, you good to go? Good to go. All right.
Okay. My name is Archie. I work for Ithaca. We run a product that maybe some of you used in grad school called JSTOR.org. It's a huge online database of academic articles. We also have books now, and we also are much closer to our sister company, ArtStore. And they recently finished moving on to AWS along with the rest of the systems at Ithaca. And we have about, I would say we're probably the canonical success story for microservices, like a lot of companies like Netflix. We've moved our monolith into the cloud, and now our public system is about over 300 microservices that are all independently deployed by all of our engineering. There are about 20. And because we have 20 engineering teams, we need more engineers. So that's why I'm here to draw your attention to ithaca.org/careers or ithaca.org/jobs to check out what we've got going on. We're hiring software engineers to work on that cool stuff that needs to be shipped to the cloud constantly. And I also brought tons of cool stickers, because we also do that.
Thank you, sir.
All right, that's it. I also used to work with Andrew, so I had to see why.
Okay, stop giving him crap, all right? Just let him present, all right? Let him, he's going to do a great job. So a couple minor things. There's one-time passwords for the Wi-Fi on sheets of paper on both tables. Grab one and go ahead and log in. There's a ton of stickers there. The bathrooms are around the corner. There's a small hallway over there. Other than that, Andrew, David, you guys are good to go.
Cool. Great. Let me share the screen and such. David, you want to join me as well? Let's see here. So I need to, whoops. Yeah. How do I share a screen? Is that this guy? Cool. Share. Is this coming through on the Hangouts? We're good? Okay. All right. Thanks, everyone, for coming. This is a talk that we put together on a hot new startup here in Ann Arbor, Censys. How many people have heard of Censys? All right. Getting some cred. So I'm Andrew. This is David. David's one of the co-founders, original researcher on the project. So we'll open up with him. I'll give a little background on what Censys is, give you a little idea of what the product is, how we got here. Then we'll talk about some of our Google Cloud experiences.
All right, so my name's David Adrian. I'm a grad student at Michigan right now, at the end of it, hopefully. I also did undergrad here, so I've been in Ann Arbor for way too long, since year 9 now. But one of the things that I did in grad school and our research team did was come up with this tool called ZMap, which is a fast internet-wide scanner analogous to Nmap, but rather than scanning one host, many ports, scans many hosts, one port, a lot faster. It takes about 45 minutes to scan all of IPv4 on a single port as compared to Nmap, which would take like a month. And so we were doing measurement mostly of how cryptography was used on the internet, using ZMap as one of our data collection tools. People kept emailing us being like, ZMap's hard to run. Can you just give me the statistic? So we did that a bit, and we ended up building a search engine backed by internet-wide scanning as a research project about 3 or 4 years ago now, called it Censys. Basically, it was just a way to search all of this internet-wide scan data that we had collected. We were sort of indexing the makeup of the hosts, like the devices on the internet, rather than sort of the content on the internet, like Google does. And long story short, that consumed more and more of our time. We were spending less and less time doing research, more and more time doing engineering and web service stuff, that we ended up spinning it out into a company. So myself, another grad student, and my advisor, Alex Holderman, partnered with Brian Kelly, who I think a lot of you know, former duo in town, and his partner, Dave Corcoran, and we founded a company around Censys. And we'll skip all the boring business stuff and just talk about the technology, what it is that we're doing, and what it takes to index all of the hosts on the internet on a daily basis. We'll note that just in here, you search Criteo on Censys, you'll see they conveniently have their own autonomous system with BGP routed block. Maybe this is a different Criteo, I don't know. But anyway, I don't know why they would have their own. Is anyone here from Criteo? Yeah. Do you have your own AS? Okay, well, great. So you guys show up great on Censys then, because that's really easy to index. I'm using CBC because, I'll make some joke about poodle or something. But yeah, so that's what Censys does. I'm not going to spend too much time on the product. Instead, we're going to talk about what it takes to ingest all of the data and make it searchable. We're going to wrap up the game.
We'll do one more pitch. You got the StockX pitch. You got the Ithaca pitch. Let's do the Censys pitch. We're doing some really cool stuff. We're hiring developers, DevOps people, data engineers, front-end web developers all over the board. We're a pretty small team right now, so we're looking to grow just a little bit because we're looking to make a pretty big impact. So we'll talk about the overview of the Censys pipeline. This is kind of a dumbed-down version, but it's not that dumbed down, right? We kind of think of the Censys pipeline in 3 stages. We have our internet-wide scanning pipeline. That's what's using the open source tool ZMap to basically hit a bunch of sources and emit a bunch of facts about the internet, right? And these scans are running, basically continuously across the IPv4 space, popular websites, ingesting CT logs, all that such. And then the original pipeline was co-located with the ZMap data center as well. We don't do scanning from the cloud. Cloud providers don't really like you to do internet-wide scanning from them. David's got a lot of experience talking to cloud providers there. So we own that hardware. And for a long time, we owned the hardware that was, basically managing Kafka queues or Kafka topics with the ZMap stream data coming in. We were warehousing this information in Google BigQuery, provide that to analysts and scientists. And then, the website is primarily powered, from large Elasticsearch indexes of this data. And so it's this big middle tier that we want to talk about today because we decided to move this to the cloud for a pretty big reason that we're calling out bold here. The original Censys pipeline stored all of its information in a database that was home-rolled, bespoke. I'll let David talk a little about that.
Yeah. So home-rolled and bespoke database on RAID isn't really a backup strategy. Realistically, wrapping RocksDB and some custom C++ logic to do stream aggregation in your database works great as a research project. Seriously, that is the reason we were able to do all this. We ran it with one box when we were looking at what are our options here. Cloud Bigtable didn't exist. There's Cassandra, there's HBase. You're well, to actually use one of these, we're going to have to buy like $100,000 worth of servers to run in a cluster, and our advisor doesn't really want to spend money on this idea because he thinks it's dumb right now. And so let's just run it on what we've got and roll our own C++ database around Proxy. So the plus side was we didn't write our own persistence layer. And this worked very well. Like on an individual box, it was far and away the fastest part of the system, and probably still is. But the problem is that like this code became really hard to handle. Like you think about the things that we were doing with it, we were doing stream aggregation. We had some batch jobs for writing the entire state of the internet onto disk to upload to BigQuery. And every time you like wrote one of these, you had to write a bunch of C++. And every time you thought about, well, what if I made the C++ more generic and we could like handle threading, we could decide how to split this up, you realize that you're just writing a query planner, and that's a terrible idea as well. So ZDB did us great for about 3 years, but we're sort of moving past it now to something a little more reliable and scalable.
And so with that, we were already pretty invested into a Google Cloud ecosystem for a lot of the app layer stuff. One of the main services we provide to enterprise customers is a BigQuery interface, so they can actually don't have to warehouse all the data themselves. And Google has Cloud Bigtable out, and which looked really attractive. They also came out with Google Dataflow, and we'll get into all these tools. There's Kubernetes. They also have a hosted Airflow now these days. So it was looking more and more like Google Cloud could replace most of the things that were in this middle section of our large pipeline, the data processing, the streaming, the batch processing. So that's what we decided to go with. Does anyone have any questions up until this point? Has anyone used any of these tools? Or can I just bullshit my way through this? We're good? Cool.
Can you explain Kubernetes, please?
I would not dare to explain Kubernetes in this crowd.
Has never stopped anyone from running it.
Yeah. Oh, sorry. So I'm just curious. So scanning all of V4, probably not a big deal. What do you do about V6?
It's an open research question.
Okay.
The first slide.
Yeah, it's I would say it's also one of the reasons we're incorporated now as a company and startup to put a lot more firepower behind this than just free grad student labor, aka David. So yeah. Sorry, was there another question?
Also, name-based scanning, detecting usage patterns. We don't do a lot of that now, but that's very helpful. Sure. Meantime, I don't know, find me a service that's only available on V6 that people care about.
David, talk about Bigtable. Why Bigtable over ZDB?
So basically what we built with ZDB was a ordered hash table. So that was what you got out of RocksDB, and we put logic in front of it for basically merging records at the IP level. So you get stuff coming in on, say, port 443, the scan data for some IP, as well as on, say, port 22 SSH, merge it all in ZDB. That operation is pretty much exactly kind of what Bigtable does. We just have an ordered, basically, hash table of bytes to bytes that you can scan through quickly for all your batch jobs. We get column version history, which lets you do consistent snapshots if you're snapshotting in the middle of a batch job so that your data can reflect the state of the world before the batch job happened when you snapshot. But at the end of the day, kind of the use case for what we're getting at here is that for any pipeline with this is that we just need an authoritative source of truth. There's lots of ways to go about things, but sort of the model that we had in our head for the authoritative source of truth was fast lookup by IP. And that's what we get out of Bigtable. We get atomic row level operations. We don't have to worry about things sort of squashing each other. We can just write to different columns and don't squash the other writes. And then the state of a row is the state of the power down to your services.
So then, the other piece of the puzzle that we were really excited about in Google Cloud was their Google Dataflow offering. So this is directly from their website. It's a unification of stream and batch processing. David, can you explain the difference between stream and batch data processing?
Well, one's stream, one's batch.
So batch processing is basically a for loop, and stream processing is basically while true. It's all you need to know. It's actually a lot more complicated than that. So it was a joke that didn't land. So Google actually created Dataflow, and then they kind of shuttered it over to this Apache project called Apache Beam. which is basically like a new version of Dataflow. But Apache Beam is this software development kit. They've got bindings for Java, Python, and like an alpha Go SDK as well. And it's kind of like this grand unification theory to allow you to kind of have like the same code base be for stream and batch processing jobs, but run them on all these like different runners that they call, one of which is like Dataflow, one of which could be like Apache Spark, all these different, like deployment operations. And it gives you this like throughput-based auto-scaling for streaming jobs, which is another thing we really want to see, right? Like we want to be able to write code that can manage these like collection of data that's coming through our streaming process, but we don't really have to worry about like, if there's like a large backlog and a pub sub queue or something like that. For the most part, like Google Cloud Dataflow takes care of, creating some number of workers based on some thresholds you give it, based on some tuning and such. There's some code on here. I'm not sure if it's of interest. Probably not that legible for people in the back, but it basically shows like, to write an Apache Beam process, you have these series of transformations. So it's like this very like functional style application on like collection types. They have this like their own type called like a P collection. But the point is like a P collection can represent a bounded or an unbounded data set. So that's where you can have a distinction between batch and streaming. And so in this example, kind of have a bounded data set, right? I'm reading just from a text file in Google Cloud Storage, doing some like word counting, some filtering on it, some grouping, and I'm writing that out to a different text stream. If this was going to be streaming based on like some pub sub queue or Kafka topic or something like that, kind of would just need to change the first line in my apply and maybe the last line in my apply, right? All that inner logic just kind of looks like it's working on a collection of information that's streaming through it. There's all sorts of other, more power user features. It gets into the whole like windowing system where you can provide these windows of when you're going to like process your data based on when like events happened, say in like a logging system versus when they sort of came into your processing queue, right? So you might get like drift of like, well, this happened on this date because someone was on some mobile app somewhere and they didn't have, an internet connection, and it finally went up to our processing facility like later. So there's all sorts of bells and whistles under the hood, and the Apache Beam crew has seemingly really given a lot of thought on how you want to unify stream and batch processing, and we've been pretty happy with it so far. What we've been happy-ish so far with Google Kubernetes Engine. You want to talk a little about that, David?
Yeah, so we originally were not going to use Kubernetes. I might get me stabbed in this room. We were just going to use Apache Flex, which lets you run containers automatically without having to deal with Kubernetes. Problem was that didn't play that nice with the gRPC services that we wanted to use. It's really kind of built for HTTP services. So we ended up switching over to Kubernetes. And then the L4 load balancer didn't play nice with gRPC, so we ended up deploying the Nginx ingress and then use that as a load balancer over gRPC services. And it was at that point where we just kind of got disappointed with Kubernetes, because that's when shit starts getting really complicated really fast. That people start telling you to just use Helm, which is still kind of a mess these days in terms of like actually keeping track of things. So kind of the state of the world with Kubernetes. So we have a few different services. We roll our own YAML for all of them. We're not using Helm yet. We have only a limited number of services, so we're able to sort of issue internally trusted HTTPS certificates for all of them manually rather than trying to run something like kubelego. So not really trying to do basically as little as possible with Kubernetes to keep it simple, just using it as a way to say like, I have some containers and I want to run this many instances, and I have a load balancer in front of a few different endpoints. And plus side is that's actually quite straightforward to do. Once we got it up and running, dug through all of the buzzwords, it's chugging quite along, especially when you actually give your load balancer enough resources to load balance. You're like, why is there stuff running so slow? It's because Nginx was hacked. We accidentally only gave it one CPU. So that's kind of the state of Kubernetes. We're treating it fairly conservatively, but at the same time, like sometimes you just had to dive into stuff a little more deeply.
Last main tool that we've really enjoyed from Google Cloud is they have a hosted Apache Airflow offering. Has anyone here used Airflow? It's an Apache project out of Airbnb. It's sort of like hit the scene I don't know, like 2 years ago, and I feel like it's kind of exploded. I had like never really heard of it until like in the past 9 months. At the end of the day, it's like this scheduler for batch processing. You can write the your tasks in this like Python DSL, and so we use this to schedule a lot of those like batch processing based on a couple of other parameters or like daily like jobs, etc. But for the most part, this is just kind of like a control center to like kick off batch processing jobs within data flow based on like other parameters. I'll say that's like kind of an annoyance I kind of have with Google data flow is that so it seems like there should be some kind of like lightweight scheduler built in, but there's really not. I mean, you have to do that via some other system. Oh yeah, and it's all based on this like new beta product out of Google Cloud Composer. It's just a hosted Airflow. Works pretty well. Putting it all together, it's not that crazy. It's the same kind of diagram we had before, except now we have a bunch of new logos across the bottom, right? We're no longer going to be using our bespoke home role database where the source of truth is Google Bigtable, and we're not using a bunch of home rolled C++ and Python stream processing code. We're using Apache Beam to handle the ingestion from the ZMap scan pipeline, and then delegate that out to the right data sources, whether it's BigQuery or Elasticsearch for the app and APIs to use. So what we've learned so far, I've learned quite a bunch. You want to take this, David? Or at least the first two?
Sure. Yeah, so Apache Beam, when we first started using it, it was really cool because we were just like, let's try processing some scan data with this. We didn't have any of sort of the enrichment services set up in the cloud yet, so things that added like autonomous system information, which is how we were able to find all the videos, basically, or things like GeoIP. So we were just ingesting some data, writing it in the Bigtable. And once we got that working, we were like, well, what happens when we auto-scale? And then it was like 100 million queue backlog, 10 workers and it's on. And you're like, holy crap, like this is great. And then we introduced enrichment services and the auto-scaling kind of stopped. And there are a couple of reasons for that. One is that unless you force data flow to parallelize a step, it might fuse it with another step. So basically the talking over the network wasn't getting parallelized at all. So we adjusted our pipeline to add in like an extra group by key to say, hey, like you can have like basically set the number of in-flight requests you wanted by saying what our max key was going to be, grouping by that key and assigning it randomly to each record. But then even still, there's a lot of fine tuning required to actually get your pipeline to scale. So actually at one point we were just running multiple instances of the same pipeline because that was running better than trying to run a pipeline with 5 workers was 5 independent pipelines. We've resolved some of those issues so far, but like that's been a lot more of a headache than we were expecting it to be. And then part of that cause is just because like if you're talking with the network, your CPU usage is probably low, and some of the scaling is based on the CPU usage. I talked about Kubernetes a little bit already. Load balancing. I mentioned that a little bit, but I guess what I'll note is we did end up having to deploy an L7 load balancer instead of an L4 load balancer, which is just like more work and like disappointing. There isn't a grpc one built into Google Cloud, so we had to deploy our own rather than just clicking like add my Google HTTP thing to it, which kind of like made us be disappointed that we were using grpc, but at the same time, like we had all these prototypes sitting around anyway, so it's still saving time for all. And then the other note is that cloud egress bandwidth remains expensive. Kind of split halfway between cloud and our data center, which saved us lots of money for our Elasticsearch cluster, but still costs lots of money to send bandwidth to said Elasticsearch cluster. Not as much as if we were just running the Elasticsearch cluster in the cloud. Not nearly as much, but still a lot.
Yeah. So just to be clear, like ES is running in a data center, and we do have a lot of like raw data dumps that certain enterprise customers can get. If they want to warehouse the data themselves, it's not like BigQuery or something like that. So even getting the data to them from the cloud is like quite expensive. Yeah. Last bullet points is just a joke, but we're in the middle of the cloud migration. Like I think a lot of people here could sympathize. Like it's hard. It takes a whole team. We've learned a whole bunch. We got kind of burnt out one afternoon and made this awesome Tumblr. We would love to get some missions. It was made by Krista Zombak, one of our team members. So it's just, certificate validations, they're not a DAG. Roadmaps, not a DAG. United States system checks and balances, no. And hopefully your company hierarchy is a tag. Rust ownership, I don't even get that one, but yeah. So yeah, actually I don't get that one. No, not a DAG. Chess is not a DAG, but checkers is, I guess. Not by me. So
But if you're starting an infrastructure startup, be sure to use the word DAG somewhere in your market.
Exactly. Yeah. You know, there's some like quick stats, you know, sort of about you know, some of the stuff we're doing. You know, we've got a lot of certificates in our data set, right? It's a growing data set. You know, Let's Encrypt is not helping with that, but it's a good thing. You know, you can hop over to our like Elasticsearch cluster, right? We're running a 35 node Elasticsearch cluster. Kind of have like 3 primary indexes across like 3 data sets. Certificates is quite large, 20 terabytes. We're looking at like 30 or you know 25 terabytes across the whole board, 24 terabytes approximately. So if anyone knows a lot about tuning Elasticsearch, come talk to us because we'd love to have you join the team because we've got some Elasticsearch to do. For the reading, you know, you can check out the original ZMap and Censys papers, anything by Zakir, David, and Alex as well. Google Dataflow, they've got some pretty good docs. Link to a blog post here, and I've got a link to our whole slide deck, so you can grab these later. Read up on Google Bigtable, and of course, yes, Censys is hiring. I'll pitch that one more time. But with that,
unlike the other people that are hiring, we gave the presentation, which means we're winning.
So yeah, that's kind of all we had. Open up for questions.
What's the biggest scaling challenge you have next year?
Well, I mean, 1 billion plus certificates, you know, going to ES doesn't help. That's going to be pretty tricky. You know, I think getting like some better handle on how we can like get data flow to interact with more of these like external enrichment services. You know, we don't want to write all of the analysis that we do on the data set in just like Java, you know, data flow code, et cetera. So making sure that you can, you know, tune a stream processor that can like efficiently call out to you know, a separate microservice is you know, still kind of like just like a, you know, a tuning problem, right? Like you got to balance some stuff. So that's tricky. That's kind of just like, I think more of like an unknown, right? Like it's depending on the service, right? Like, you know, we could hire some data scientist that's really bad programmer, right? And they're doing some analysis on it, and just slows down our whole stream processor. So that would suck. I don't know if you have anything to add to that.
Yeah, those certificates is just getting bigger and bigger. I think Chrome flipped the not secure bit today or yesterday.
Yeah.
Yeah, and then the other thing is that Elasticsearch is good for searching, and then like Bigtable, you know, gives you like lookup by IP. We're shooting to sort of introduce like faster API once we're more settled in Bigtable, as well as like historical APIs that are storing the history of every host. That's a pretty straightforward scaling problem, although it is going to be big, right? It's just like, right, instead of writing current state and overwriting, also write to like and only Bigtable log. But when you start talking about, well, let's work on future Censys product. Let's do analysis on the data we have to help people solve problems rather than just offering the data as a service. Well, you can't really run queries on your Bigtable cluster without writing like a map reducing early.
Brendan.
Are you using Nginx as a layer 7 load balancer for gRPC?
Yep.
Is there a module for it, or is it built in?
It's built in.
It's protocol aware.
Yep. They added it, I think, about April of last year.
And why did you need layer 7?
So basically, we have a couple of services that can only handle a very small number of connections per host. And so we deploy lots of instances of it. And when you're contacting that from a single data flow worker, your L4 load balancer is likely going to always route you to the same instance on the backside, or if not always, still like fairly often. And then you just get like kind of
Question in the back.
well, someone else already does the content. Oh, so the question was, what's the business value of indexing hosts versus content? And the answer to that is basically that the configuration of a host and what a host is and where is it, who does it belong to, has tremendous security value. You can't defend what you don't know that you have. And so the data, so some people are capable of ingesting that kind of data themselves or searching for their own stuff. There's lots of niche use cases, but the broad sort of umbrella is looking for things to defend. Some people do that themselves. We're working towards building products to do that automatically for the people that can't do it themselves. So,
but did you have Beam in your on-prem data center?
we did not. We did all of our stream processing in our database.
I was curious how it compared.
How compared to what? Oh yeah, no, we haven't ran it on anything.
So what about GCP is the best thing? What is the worst thing in terms of anything, usability, function, performance?
Oh, that's a good question. I think Stackdriver is like a blessing and a curse. It's it has it's this mirage on the horizon of holy cow, it can do so much stuff automatically, right? It's very impressive, the dashboards, and monitoring we can put together, just based on data flow, emitting metrics to it automatically, right? Didn't have to configure anything. But I don't know, it's I don't know, it's just a bad thing to complain about, but we were just complaining about this earlier. Grafana is just better, right? So nicer web UI or stuff like that.
Label your axes and your lines.
Yeah, yeah.
Units, you can get rates.
Yeah, so I know that's kind of a weak answer, but I just wish Stackdriver was a hell of a lot better.
Okay. Out of all the things, load balancer configuration.
Yeah, I mean, I don't think we're
The best thing is definitely that you can add an SSH key to a VM after you created it.
Yeah, yeah.
So would you say overall, GCP has been a really positive experience migrating there?
Yeah.
You're
Yeah.
already running the website on App Engine since
Yeah, and we'd already been on BigQuery for a while, right? And Bigtable really applied to the problem domain, and so there was enough of our data sources, our sinks, that was kind of a no-brainer just to go into Google Cloud.
Other questions?
You unpack your Helm challenges?
Helm. Oh, I thought you said Elm.
Yeah, I mean, just
know.
the short version of it is that it was something else to learn. It was for the Nginx one, there didn't appear to be a quick way to make your load balancer internal versus external without modifying the Helm chart itself. And if I'm modifying a Helm chart, itself, rather than trying to figure out how to configure Helm, set up the service, store my modified Helm chart, or my Helm configuration, until we're talking 3, 4, 5 major things in your Kubernetes cluster that require multiple pieces to talk to that we didn't run. Basically trying to avoid introducing more things.
We had similar problems with that. Have you been happy with Helm stuff, or
We just realized that we were going to write Helm if we weren't using it. So that's why I wanted to.
They're hiring for a Helm engineering position.
Yeah.
Right? That's dedicated.
But yeah, that's kind of the conclusion. Wait, we're making templating systems for YAML files, and
I mean, I did talk about templating system for YAML, but
Except we use Go and Bazel. So, yeah. I mean, that's also selfishly why we come to a meetup like this, right? We need to learn more about it, and have I mentioned we're hiring? So,
so we haven't used anybody else's Helm stuff much.
Okay.
We've kind of had to look at them and rewrite them.
have you looked at customize with K?
of course, it's with a K.
So,
Not yet.
so I'm taking early next year of myself doing a presentation. Because there's Cubecorn, Customized, Helm, and 18 other ones that I don't know what fingers for.
I think everyone's annoyed at everything.
Yeah.
Package management is
not
not.
I have a quick, how many environments are you doing with Kubernetes? So namespaces, I guess, are you doing?
3?
3 or 4 or 5, basically one namespace per logical app unit, just kind of reasonably well for us.
So
all of our CT sync is in one namespace, our Elasticsearch loading is in another.
big one for us with Helm, and it's only been a very recent thing, was not having to have configuration. So configuration per environment, right, per namespace. We actually did get some of the annotations working for internal versus external load balancers. It was a little bit of a steeper bind, but it hasn't been terrible. Actually, the reward has been pretty.
Yeah, I'm sure that we'll end up there.
Yeah.
It's just at the time.
No, that's cool. Yeah, it was not a cheap learning.
My gut sense is that in like a year or two, Helm will be a lot better.
Yeah. Oh, I think they're still developing just like they're
Helm
on.
2 is like.
Awesome. You guys will be able to talk to these guys after, at the end of, we'll be hanging out, I think. No, they're just gonna run, that's fine. Well, you're not gonna get anyone
Pretty
else.
reserved, kind of an introvert. No, of course, yeah. Oh, we're hiring, so, yeah.
So up next, we're gonna have a lightning talk from Jerry on his take on the CIC. I'm gonna give everyone 5 minutes to go to the bathroom, get more pizza, get some muffins, if there's any left. And Jerry gets set up, and we'll be back on in 5 minutes.
If anyone needs Beer Fest tickets, I'm selling 4.
Sounds like a recruiting tool.
Face value.
He's got 4 of them.
Yeah, it's a long story.
I'm actually.